Hello, I'm Andrew Shimshock, co-founder of Milpond Research. Today, we're addressing the critical challenge of deploying generative AI to the tactical edge to improve the resilience, efficiency, and effectiveness of military command and control, or C2 systems. The scope of the problem is a severe compute and bandwidth bottleneck. As the DoD integrates AI to accelerate decision making, we face a paradox. The most capable models require massive compute and constant cloud connectivity, which are unavailable in denied, degraded, intermittent, or limited, or DDIL environments. The current state of the art forces commanders into a compromised choice. Option 1: tether C2 systems to cloud based APIs. The limits here are obvious: high latency, massive bandwidth costs, and catastrophic vulnerabilities to network severance and data exfiltration. Or option 2: deploy massive large language models locally. Here, the limit is swap size, weight, and power. You can't put a server farm in a Humvee or a submarine. And currently, every time an operator asks an AI question, it triggers a full, computationally expensive generation cycle, even if the operator next to them just asked the same question. This is redundant processing that drains power, consumes bandwidth, and creates unacceptable latency at the tactical edge. Milpond Research advances the state of the art through its Xilos platform. Xilos is an intelligent middleware layer that sits between C2 operators and the AI models. Our unique insight is that we don't need to shrink the massive models. We need to eliminate redundant compute. We achieve this through our dynamic learning cache. When an operator queries intelligence data, Xilos uses advanced semantic similarity search to check if that question or one contextually identical has been asked before. If it has, Xilos serves the validated response directly from the local cache. This is our new approach. We are shifting the paradigm from compute on demand to an intelligent retrieval. This drastically reduces latency, slashes API costs, and ensures that tactical edge C2 systems remain highly efficient even when disconnected. But efficiency is only half of the equation. Resilience is the other. As an added benefit, Xilos provides fit-for-purpose model routing and an AI-native security. Xilos intercepts every prompt in real time. Simple tasks are routed to small, local models, while complex tasks are routed to larger models when only when bandwidth permits. Simultaneously, our proprietary small language model acts as a security gateway, automating the sanitation of prompts to prevent classified data exfiltration or shadow AI, and blocking adversarial prompt injections. It gives U.S. forces the cognitive overmatch of massive AI at the tactical edge, but with a fraction of the hardware footprint and absolute data sovereignty. The primary barrier we foresee is managing this cache staleness in rapidly evolving battlefield scenarios. We will overcome this by implementing dynamic time-to-live protocols tied to specific intelligence data streams. If funded, our strategy is to optimize our small language model for edge hardware, specifically targeting systems with 48 gigs of VRAM, and pilot the semantic catching engine against simulated high-volume C2 query datasets. And before starting this company, I was at NASA, building real-time data systems for the wind tunnel, where failure wasn't an option and air-gapped environments weren't just a preference, they were a requirement. My undergraduate degree is directly in AI machine learning development, so this isn't a pivot for me, this is what I was built to do. After government, I made a deliberate move into the private sector, where I needed to understand what best of breed looked like, what speed, scale, and modern tooling demanded. That combination of top secret security practices, deep AI expertise, and private sector velocity is rare, and that is exactly what this project requires. My co-founder and brother, Peter Shimshock, is our Chief AI Officer and an active member of the US AI Safety Institute Consortium, helping shape the NIST AI Risk Management Framework. Peter brings bold, cutting-edge AI ideas to the table. I run every single one of them through a security lens. That tension between innovation and protection is what makes us different. There are a lot of talented teams in the space, but few have built patented AI infrastructure from the ground up, secured a strategic agreement with the DoD, and operated at the intersection of national security and the frontier of AI from day one. We don't just talk about securing AI for the mission, we built a whole company to do exactly that. The impact of Xilos is immediate and measurable. In the defense space, the primary use case is in tactical operations centers and naval strike groups. By implementing Xilos, a carrier strike group can reduce its AI related bandwidth and compute overhead by 30 to 40%. If the network is jammed by an adversary, the C2 system doesn't need to go dark. Xilos continues to serve critical, cached operational knowledge and route new queries to light rate on premise models. In the commercial sector, this technology directly translates to critical infrastructure and remote industrial operations, such as offshore drilling platforms and remote mining sites, where satellite bandwidth is astronomically expensive and the data security is paramount. The so what of this? Generative AI is too resource intensive and insecure to be plugged directly into strategic systems. Xilos provides the mandatory orchestration, caching, and security layer required to make AI fast enough, cheap enough, and secure enough to actually fight and win at the tactical edge. Thank you for your time and consideration.